everyone. I'm Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on definitions and terminology on choppers. So that is third module. So now here in this we have total 15 definitions. The first definition is a chopper. What is meant by chopper? Define chopper. So chopper is a DC to DC converter. So DC to DC converter means why DC to DC? So now here supply voltage is fixed. So if suppose supply voltage is fixed, so now sometimes we need variable DC output voltage. So for that purpose we will use this chopper circuit. So there is a switch and there is a variable DC voltage is converted into the fixed DC voltage is converted into the variable DC. So the chopper is a device which converts fixed DC to the variable DC output voltage directly. So now second definition is here. So now describe the duty cycle. Duty cycle in the chopper. So first see the definition first. The duty cycle or power cycle is a fraction of one period in which signal or system is active. Actually in the chopper duty cycle is represented with this symbol delta and T on divided by T, total time period, and turn on. So now duty cycle is commonly expressed as a percentage ratio, and a period is the time it takes for a signal to complete on an on and off cycle. So now this is the duty cycle, the ratio of turn on and turn on and total time period. So here time period equals to T on plus T off. So now here in the chopper we will use switches on, sometimes switches off, T on, and there is a T off. So now this is a time period. So now here duty cycle means the ratio of turn on to the total time period is known as a duty cycle, or duty cycle equals to T on into frequency equals to 1 by time period. So now here depending upon the duty cycle the output voltage will changes. So now it will changes from DC to DC converter, from fixed to variable. So now here V0 equals to delta into Vs, supply voltage. So now here this is input fixed DC voltage, this is variable. So delta is changing depending upon the switching turn on and turn off switching time. So now here, so this is only for buck converter. For boost converter, so that equals 1 by 1 minus d Vs, V0 equals. So that we will see in the next here. Next third one, describe the current limit control. So now here this duty cycle, this output voltage changes depending upon this duty cycle. So duty cycle equals to T on divided by T here. So there are two methods. So first method is here current limit control, and another one is a time limit control. In the time limit control, constant frequency control and variable frequency control. That I will explain in the next definition. So first, current control limit means thyristor is turned on when current when then flow of current spreads minimum level. So now here this is the output current or load current, and it let me change the color over here. So now this is current spreads minimum level. This is turn on and reaches to the maximum, and next now this is for this case. In this case, so thyristor is turned on here. For this case, thyristor, when flow of current spreads to, this is turn on state, and after that when it is reaches the maximum, this thyristor can be turn off. So when it is reaches to the maximum, it will be turn off. This is T off. So again it is turn on and it is turn off. So now here chopper is turned on when current flow spreads the minimum level and this technique can be utilized either when on time is endless or when supply frequency equals to 1 by T. So now here from this you can change the duty cycle. From the duty cycle we can change the V naught equals to S delta into Vs. Now here, so one current control limit, first one, second one is a time ratio control. In this either delta equals to T on divided by T. Either T should be changes, and one should be constant, other one should be changes. So now here, so in this again two types, constant and variable control. So now time ratio, either T is changing, varying, or T is changing in order to change the duty cycle. For changing the output voltage, V naught equals to delta into Vs. If we change the duty cycle, if we change the T on, either T on, so duty cycle changes, and output voltage changes. Otherwise, here second one, either T changes, so duty cycle changes, and duty cycle changes means output voltage changes. So time control in this, so the time ratio control, either T on or T can be varied, or in order to change the duty cycle for changing the output voltage for the chopper. So now in this again two types, so constant frequency control and variable frequency control. So first constant frequency control I will explain. So constant frequency control means, so now here duty cycle equals to T on divided by total time period. So now here constant frequency equals to 1 by time period. We know this, we know very well this formula. Delta equals to T on into F. So now here F should be constant. So this should be constant. So means T should be constant. T should be constant. So means here in the constant frequency control, time period is fixed. So this should be fixed. This should be fixed value, and T on is changes. T on is changes means duty cycle changes. Duty cycle changes means this is Vs, this is output voltage. In order to change the duty cycle for varying the output voltage of the chopper. Next, second one is a variable frequency control. So variable frequency control means here in the variable frequency, time period is, so delta equals T on divided by T. So in the previous one, constant frequency control, so this is fixed, but here this should be variable. So delta equals to T on into F. So frequency should be variable, frequency should be changes, means that means time, this time period should be changes, and time period changes, and T on should be constant. T on should be constant, so T on should be fixed. And next, Vs into delta equals to V naught. Same way here in the variable frequency control, the on time turn on time period is fixed constant, and T time period or frequency is changes in order to change the duty cycle for varying the output voltage of the chopper. So now here, so now frequency control. Now step down chopper means that is buck converter. So now here, so output voltage and supply voltage. Output voltage is less than the supply voltage. So output voltage is the less than the input voltage, and this is the output voltage V naught and Vs. So that chopper is known as the step down chopper. So now here, when the output voltage is less than the supply voltage, that is input voltage. So now V naught equals to delta into Vs for this case, and delta changes from 0 to 1. So delta equals to delta equals to T on divided by T. This is the formula. Now, step up chopper means output voltage is greater than input voltage. So this is the Vs, V naught, and this one is the Vs. And next here in this case V naught equals to 1 by 1 minus D into Vs. This is the formula. D equals to D changes from 0 to 1. So now output voltage is greater than input voltage, then that converter is known as the step up chopper or boost converter. And next, describe class A chopper. So what do you mean by class A chopper? So class A chopper, see here, class A chopper means here first quadrant chopper. When chopper is on, V naught equals to Vs. So now here first quadrant chopper means if you draw the output voltage and output current, this is the output voltage and output current. Let me change the color over here. So this color. So now this is the first quadrant chopper. It operates in the first quadrant. If you see the circuit diagram here. So now here, first quadrant chopper means, so I naught is positive and V naught is positive. So I naught is positive means, so supply current is always flows from supply to the load, means power is flows from supply to the load. So now here this is the supply voltage, there is a switch, and there is a freewheeling diode, this is the inductor and capacitor, and this is the load. So power is flows from source to the Vs to V naught, source to the load. Current flows from source to the load. So the best example for chopper is the buck converter. So now here Vs is greater than V naught. Buck converter, step down chopper. So it operates in the first quadrant only. So now in the second chopper is class B chopper. So class B chopper means here, class B chopper, it works in the second quadrant. Second quadrant means here, this is I naught and this is the V naught. So in the second quadrant chopper, it works in this. So now here, this is minus P naught and I naught. So what about the circuit? This one, and they see here is a switch. And there is a diode, and next this is the supply. Here this is the load. Here in the second quadrant, current is negative. So current is negative, I naught is negative means current flows from the load to source. Current flows from load to source means, so that in that case, so current is from load to source means, for that case, in that case, power flows from load to the source, and that Vs is greater than V naught. So this is V naught is greater than Vs. So means this is step up chopper, that means boost converter. So now here chop B copper works in the second quadrant, and that means output voltage is positive, V naught is positive, and output current is negative. This output current is negative. This type of chopper, in this type of negative means current flows from load to source, and power is flows from load to source. This is step up chopper because output voltage is greater than the input voltage. Now class C chopper. So class C chopper in this. So class C chopper, this is I naught and this is V naught. It operates in two quadrants, first and second quadrants, means the parallel combination of type A and type B chopper. So now here in this, so this is a type A chopper and type B chopper. You can call it as class A and class B. So now here first and second quadrant. So the parallel combination of the diagram should be here. This is one switch, and this is one switch, and this is one diode, and this is one diode. The diagram should be like this, and there is an inductor and there is a source. And here, this is the diagram. So now in this case, so now current output voltage is positive, and I0 is either positive or negative. So now chopper type C chopper is a parallel combination of type A and type B chopper. The output voltage is always positive. Output voltage is always positive, but output current either negative or positive. Either negative or positive. This type of chopper works in first and second quadrant. Next, describe the type D chopper. Type D chopper means here. Type D chopper means here it works in the. So now this is the I0, V0, minus I0 and minus V0. It works in the first and fourth quadrant. So first and fourth quadrant. This is first and this is the fourth quadrant, second and third quadrant. So it works in the first as well as fourth quadrant. Therefore, output current either positive, I0 is either positive or I0 is either negative. But V0 is always positive. It should not be negative. Output voltage V0 is either positive or negative. So output current remains positive and output voltage either positive or negative. So the diagram should be, so this is one switch here. The diagram should be like this. So this is one switch and here is a switch and there is a diode and there is a diode and there is a load. So the parallel combination, and next it should be like this. So now here class E chopper, 13th question. Chopper, so it operates in all four quadrants. So I0, V0, minus I0 and V0. So minus V0. So now here it will operates in the all four quadrants. So first, second, third and fourth quadrant. So now type E chopper is four quadrant chopper. So chopper is parallel combination of two type C choppers. So if you connect it to parallel combination, back to back connection of two chopper C, two type C choppers. Next, 14th question. Define buck boost converter. So buck boost converter means here buck boost converter is a type of DC to DC converter that has output voltage magnitude is either greater than or less than the input voltage. So now here in the buck boost converter, either V0 is greater than Vs or Vs is greater than V0. V0 is greater than Vs that is boost converter, and that is if it is Vs is greater than V0 that is buck converter. So now here, so it acts as a boost converter and buck converter. Now here, so this diagram for this one, here the diagram for this one, the diagram for this one here. So now here this is the inductor, this is the diode, and this is the inductor, and this one is a switch. This is one switch and this is the inductor, and there is a capacitor and there is a load and there is a supply voltage Vs, and this is the V0. Now here either V0 is greater than Vs or V0 is. So now this value equals to Vs equals to d by 1 minus d into Vs. So this is the formula. D is the duty cycle. So now in case of boost converter, in case of buck converter, V naught equals to S into Vs. So now here in this case V naught equals to 1 by 1 minus d into Vs. So now this is for buck converter, this is for boost converter, and this formula is for buck boost converter. So this is the circuit diagram for buck boost converter. So now here switched mode regulator. They describe the switched mode regulator means voltage regulator that uses switching element to transform the supply to the alternating current, which is then converted into the different voltages using capacitors, inductors and other elements. Then the converter is back to the DC. So this circuit includes regulation and filtering components in to ensure a steady state output. So now I hope all these 15 questions are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.